are the cooling pipes that keep it cool. These are the xenon arc lamps, or mercury vapor, and they emit the light. They reflect off these reflectors. They bounce off of this, and all this light goes. This is a cross cutaway view of the underneath of the array. This is what it's called, an array of xenons. So when you hear the word array, we're going to get a little later. This is the whole trick. If you understand that spinning thing I'm going to talk about, this is it. This is a cutaway view of this, and it's just amazing, and we're just going to jump into it. Let me read. I'm just not going to read this whole thing. You can do this yourself as well. Let me touch on some key things that just unlocks this whole thing. To be used to simulate not only sunlight, but earthlight and moonlight. In order to provide sufficient illumination to simulate sunlight over a practically large area. That's why it's there. It is necessary to employ plural light sources, many of them. That's why it's an array. It is desirable to control the intensity of the illumination by varying the number of light sources that are energized. And let's skip ahead. Here we go. See this little arrow? This is it. This is going to blow your mind, and we're going to stop. The array of light sources included in the simulator below. Figure 4. Okay, figure 4. What's figure 4? Let's go back to figure 4. Right here. Okay, that's just a cutaway piece. And there's actually another one in there as well. So we back to the main. We're going to be talking about this piece right here. Figure 4 is a cutaway of 34. One of the components of 34. What is that? This is where it gets good. Don't miss this one. It is in a large cross-section of the plurality of hyperboloids of revolution. That means it's going around and around. You want to know what that is? Well, let's just watch a quick video of what a hyperboloid of revolution is. So here we go. This is a hyperboloid of revolution. Okay, see that? Now I want you to imagine with me that there was a cluster of these according to the document. So I want you to imagine with me that there is another rod on the other side of this. Not just one side, but the other side. In fact, one here, one there, and probably 6, 7, 8 side, a whole cluster of them. And in this particular, when this thing rotates enough, it would simulate a 3-dimensional hyperbolic paraboloidal shape. So a cluster of these. Now, that little cutaway view we're going to look at is a cutaway view of this. One of these blades. This is a bar here. So this is for you to help understand what we're looking at here. Okay, so this is a hyperbolic paraboloidal shape. When it spins around fast enough, you get this shape. So, remember those little blade bar things we saw spinning around and around? Well, those are the highly reflective blades that are spinning around and around. They got to be like not just 2, 4, 6, or 8, probably 16, or a cluster of them like it said in the document. Here's the interesting part. So, the thing is spinning along the axis of this arrow. The light that's going to be directed is going to be hitting this between those blades. The extra light that comes out that makes it between the light blades comes out on both sides of this thing, as we're going to see in the diagrams. So just like we see these beams of light coming out are actually off the edges coming out of the sides of the hyperbolic paraboloidal shape. And that's exactly what this is. And we see 2 beams, one from each side of the blade. Now, Scott Sion captured this image with his own camera. Let's look and observe what he caught. It's pretty crazy. I'm going to let him play the audio as well.
Taken some daily pictures of the sun, and this is the first time that I have ever gotten this type of effect. I took a few of these still photographs and consulted with Dr. Elbers, and she was pretty thrown back at what we're seeing.
Okay, so I'm going to mute that, but I also, not that we don't hear from Lovely Scott, but I need to talk. So I want to point out some interesting nature of the light that we have. Let me pause this right at any one of the points along this video. I'm going to show that you can clearly see the hyperbolic shape. And what we're looking at here is sun from the sun simulator pointing straight at the hyperbolic shape. Like we see here, the light is entering into one side of this hyperbolic spinning blades, forming this shape, and the remaining light that gets trapped between the blades comes out these sides coming off of these beams of light. We see those are the spiraling cones of light. There's two of them because there's two sides to each blade. Now, let's continue. And once again, we see footage from around the world of these hyperbolic paraboloid shapes. A bent camera. In fact, we get to see it flashing across the camera in slow motion. If you haven't seen the slow motion, you can go back and see it again. Those spiraling cones of light, you could see there's nobody behind them. There's nobody smoking, vaping. You'll even watch this in slow motion and notice that smoke, vapor, breath, it doesn't matter. It all goes up. It does not spiral. It does not go down. And it does not move at the speed that this is moving at. No way. Let's just keep watching. I'm going to slow this down. So this is full time. How fast this thing is spinning. It's got a rotation speed. Again, here we look at these cones of light are from the sides, coming out the sides of that paraboloidal shape. And we even get to watch it move across the screen. Did you miss that? That was real-time speed. That's how fast it is. You tell me, what kind of smoke moves that fast? I had to slow this down, quarter speed. Look, let's watch that again. Pay no attention to this little lens flare bouncing around. It's a camera. Did you see that spinning? And you're going to see it again. Right there. Let's play that one again. I showed this so many times. The spiral there. You see that? Unbelievable how many people want to say that that's smoke, breath, or vaping. Sorry. That's your spiraling cones of light. Got more proof? It just keeps coming. So, let's look at some more evidence of this. Okay, so let's go back over the sun simulator patent. So what we're looking at is a cross view of it. We're looking at this. These are round lenses. And according to the document, this is 25 feet in diameter. And this is 30 inches. Actually, this is 30 inches. And we get to see... Actually, let me go to the highlighted copy. I had to go and re-highlight this. So we covered... So here we go. A hyperbolic reflector. It bears relationship with a parabolic reflector so that when a virtual focus of the hyperbolic reflector at the focal point of the reflector are coincidental and the light reflected from the hyperbolic reflector. Yeah, it just gets complicated, and I'll try and explain that. It's just the angles of... Actually, just keep reading, and I'll explain the angles of light. It's necessary, however, the center axis of both reflectors are coincidental. That basically means that the angle of light that's reflecting off both the parabolic dish and that parabolic thing we just looked at are coming off it from reflecting at the same angles. 40 degrees. And here it says when the main downwardly facing parabolic reflector is about 25 feet in diameter, which is where I showed you earlier. This right here. That was the main reflector, the biggest one. That's the missing piece we still need to see. So if anybody wants to leak that forward, send it to any one of us. We'd gladly show it out there and finally put this piece together. I'd like to see this thing reflect. So let me read a little further. It said one real light source is parabolic dishes. Pretty much a lot of mumbo jumbo. So with all that, let's go back to this diagram here and cover that. So this is a cutaway view of this reflector blade, figure 4, which is a cutaway view of one of those blades that I talked about. This is what's reflecting the light. This angle, 40 degrees, when the light comes from this angle, it's going to bounce off. It matches this angle up here. This is also 40 degrees. Now here is where NASA has been telling all of us, including the debunkers, that yeah, that sun simulator we keep pointing out is only a little test thing because they're testing it. That is correct, but that's not the whole truth. Because what this is, according to this diagram, this piece right here is the test. This thing is the test. This thing here. It was called number 10. We can go back. This is the testing unit. This is the lens, number 28. And what are they testing? The sun simulator. Okay? So they're testing a sun simulator. This is the lens. So this is the light culmination that we saw. That big disc, we're looking at it sideways, bounces this light, comes through. This isn't a test lab though. Okay? But they're testing a sun simulator because you don't put something in space until you test it first. They don't drag the whole thing up there and turn it on and the angles are right. It doesn't even look right. So they want to test it here on the Earth. So those dimensions are going to be accurate. So the light bounces off this. It hits this hyperbolic reflector. It bounces this. All the light, you can see the arrows, comes down, goes through this lens aperture, which now this is no longer here during in the test lab because they were testing it. But they removed all this. And so the light comes through here, through this aperture, through this lens, and they could change the focal point here. This figure 30 is pointing out this multi-facet reflector. And the reason why it's a multi-facet reflector, like we see here, multi-facet reflector. Why would they need a multi-facet reflector there? That's because when they turn on the lens array, if one of those xenon lamp goes out, it evenly distributes this light all the way back to the main. Let me show you again. If one of these reflectors fails or turns off during the cycle of turning these off and turning it on, remember, maximum light brightness is all fire in all cylinders. If they want 25% light, they turn just 25%. It's not really a dimmer switch. They turn more of the lamps on. So if one of these will fail, this thing will evenly distribute any one of these completely evenly across this dish and then bounce it back through this main lens here. Okay, now this is that was the test lab version. Here is the working version. Now they removed the whole test facility. Now they got the thing out here and moved this thing forward and put the reflector dish up here. Now this reflector, we have missing this puzzle all right here. But now we know how this thing works. This is a spinning, what did I call that thing? Rotating. So here's the whole thing. A plurality of hyperboloids of revolution. Now it took this figure 3 is a fragment of the bottom view of the array of light sources. So there's your whole key. When I saw that, I was like, holy smokes, we got him. That's exactly what we're seeing. And so let's look at some more evidence of this parabolic effect. Look at that. Here's our parabolic effect right there. And here we see the sun sideways. This thing's spinning sideways right here. And And we got more where that came from. Let's look at a sun simulator from the space station. Actually, let's look at this spinning disk once again. And now knowing what you're looking at. This is Zion Warrior channel seeing the spinning disk. Not a disk, a spinning wheel that's got, like I showed you in that diagram. No, that's another component. I only know the shape of it and why it reflects light the way it does. We don't have actual pictures of it, but the evidence on the ground certainly supports it. So many debunkers want to say that that's an artifact in the camera, and cheap cameras have been manufactured to do this. Here, look at this.